going to introduce Julio Rezende. I apologize if I mispronounced your name. He's a researcher on sustainability in arid and semi-arid regions and in space habitats, observing the aspects related to management, psychology, engineering, food production, and smart sanitation. Today, he's here to talk about Lunar Green Habitat, self-sustainability management. And welcome him to the conference and look forward to the talk. Take it away.
Okay, thanks so much for the introduction. And then I'll be starting my presentation. And then this research we have two authors. In this case, Davi Souza from Brazil and David Mascarenhas from Portugal. And then the name of this research is Lunar Green Habitat. And then also we'll be talking about self-sustainability management. And, okay. Here's a quick introduction. This research proposed a lunar self-sustainable habitat, and the name of the proposal habitat is the Lunar Green. And then the challenge of this research was not only examine the human presence on the moon, but also think about how this permanence will be self-sustainable. In this case, this proposal was a result of a partnership of researchers from Portugal and Brazil during the 41st Habitat Marte analog virtual mission. Okay, and then this is the crew of this mission, the 41, the mission 41, and then happened in the month of May. And then I will be talking very quickly about Habitat Marte Space Analog Station. We are located in the southern hemisphere in the Rio Grande do Norte state, in the corner of South America. And then I live in the city of Natal in the coast, and then Habitat Marte is around 100 kilometers or 60 miles from Natal in the countryside. And then we have a great change of the landscape, because in the area of Habitat Marte is very dry. Okay, and then here we have some results of the missions, because our missions were based in situ missions happening in our station, but since coronavirus pandemics, we suspend the presential missions and started the virtual missions. And then the last 4 months we are operating the virtual missions. And then in this graphic we have some results of our missions. And then this year is happening the 90th mission. Also in this year 108 analog astronauts and almost 2,000 hours of simulation, and also 96 days of missions during 2020. And then we can see more than almost 200 astronauts in our analog program. And then some fact sheet is the station with the largest number of annual missions. Also because we have more 5 months ahead. Also the largest greenhouse and food growing area. It's the only space analog station in the southern hemisphere, and also with an aquaponic system in operation worldwide. And also it was the pioneer station operating virtual missions, and is the second analog space station with the largest number of missions and participants, with more than 180. And then going to the presentation, I'd like to, the structure of this presentation, we will be talking about the definition of the transportation system to Moon. Our missions are in Habitat Marte is based in Mars, but in this specific mission was about Moon habitat. In this case, we will be talking also about the definition of main facilities and features of space habitats, review the proposals for model of lunar habitats and features, and also the proposition of a concept of a green moon self-sustainable habitat. And then in terms of the transportation system, we consider the possibility of use the Starship to build the lunar habitat, because it's considered a very big payload area to carry the models to be building the moon habitat. And then in our concept, we are imagining the habitat with three main facilities, okay? In this case, the main station, BioRegenerative Life Support System, okay? And in this area is area responsible to produce food, and also the engineering center. And then these three facilities would be important to start a moon habitat, okay? And then we have this graphic from ESA. They are talking about a near term lunar base, and also a mid term, and also a long term. And then we are in the concept of the main station, BioRegenerative Life Support System, and engineering center. We are based in a second moment, because we are also is a moment to try to see sustainable, try to produce food in moon, okay? And then we are based in a try to operate in terms of sustainability, and then in about this possibility, we'll be considering technologies related to sanitation, to recycle the sewage, also the food production, and a third important element is related to energy production and management. And then we review some proposals of models of lunar habitats. In this case, we examine the experiences of Bigelow, Pneumoplanet, Remnant, Lunar Horizon, and Urban and Moon Village. Okay, I'll be talking about try to be quick in terms of the discussions of these models. And then about each facility, we research to describe the research group and main researcher, website, features and characteristics, also sustainability issues, strengths and weakness, and also general considerations, and the status of support the technology development. And then relate about we'll be talking about the two experiences, and then to see how these experiences are operating, are not operating, but how these experiences were designed to be operating on the moon. First one proposal is the urban lunar-based 3D printing. And then this concept is interesting because the urban is a Germany OHB system, okay, with a partnership with some research groups and companies. And then here we can see something interesting about this concept is a lot of knowledge related to the 3D printed. In this case, they would be considering the use of regolith, and also try to produce ceramics and glass in situ, and also try the search to use the right performance of polymers and plastics, and also try to the use of the metal and alloys. In this case, you can see two elements, regolith and glass and ceramics, being produced in moon, and also two other two elements being carried, transported from Earth. In this case, some interesting technology that they are considering is the solar sintering, also the electron beam additive manufacturing, fused filament fabrications, and also lithography-based ceramic manufacturing. And we found interesting document presented in International Astronautical Congress in Bremen, I believe from some researchers of the concept, like the Sigambati, Berg, Ross, and other authors. And in this paper, they are presenting a lot of details about how this the process of 3D printing would be operating in Moon. And then let's see here something important. And then they are talk about the use of many 3D printing elements. Okay, and then about the urban lunar base. This is a content of the ESA that I was talking about. And then they are talking about the 3 phases of survivability, sustainability, and also operationability. And then in the proposal of urban, they are considering a different approach to additive manufacturing. Okay, how this will be operating in Moon, and also relate to sustainability. Okay, they are trying to use materials more based in Moon. Okay, and then strength would be considered good content in many studies of European Space Agency. And then we also need more time to analyze the data that we found. Okay, and then now we'll be talking about the second concept, the Moon Village. And then the Moon Village is the research group is based in European Space Agency. We can find some websites about, and then we related to this concept, we found two concepts. One proposed by ESA in 2016, and another concept shared in 2019 with a participation of the groups of Skidmore, Owens, and Merrill LLP. Okay, and then we will talking about these 2 experiences in terms of design of the Moon habitat. Okay, in this case, is the concept of the Moon Village is a collaboration between the European Space Agency. Okay, and also was presented during the 32nd Space Symposium in April of 2016. Okay, and then they bring some private actors to the discussions also. And here in this image, we can see how would be the concept of the Moon habitat. And what they are calling Moon Village is based on resilience and self-sufficiency as the key design principles. The master plans envisions the Moon Village, okay, in the location of Shackleton crater, okay, in South Pole. Okay, and then some general observation about this concept. Okay, is a beginning concept instead of the developed of European Space Agency. And then I'll be talking now about the second concept, developed with the partnership with Skidmore, Owens, Merrill, LLP. Okay, and then they call this design of first full-time human habitat on the lunar surface. Okay, and developed by also European Space Agency and with partnership with Massachusetts Institute of Technology, MIT. Okay, and then we can see in the next slides a lot of content, interesting content in terms of design. Okay, extensive experience in architecture, engineering, urban planning, and sustainable design, and bringing a holistic approach to the project. And then here in this image, you can see the concept of the Moon Village, and then in the back, you can see the planet Earth. Okay, and then we'll be looking some images about how this This proposal is based like in the classification of European Space Agency, like in a third moment when we have a lot of facilities operating Moon. Okay, and also we can see in the first proposal of presented by ESA in 2016 something more in terms of more modest, and here we can see something more ambitious in terms of our Moon habitat, and the concept how would be the landing in Moon, some design of urban planning of Moon habitat. And then in this concept, the organization SOM developed a concept of 3 phases, proposing several critical infrastructures, components, and habitable structures, and then also using the challenge to use the in situ resource utilizations, also generating food and life sustaining elements, using the natural resources from the Moon. And then they are considering the use of water from some shadowed depressions near South Pole, where they would be collecting the water to produce breathable air and also rocket propellants for transportation. Okay, and then it's very important in this concept be clustered in a crater based in water ice deposits. Okay. Then, in terms of sustainability, the Moon Village will be based on resilience and self-sufficiency as the key design principles. Okay. And then, related to the Lunar Green Habitat, self-sustainability management, related to our research, we design a station based in three facilities. In this case, the main station, the BioRegenerative Life Support System, and also the Engineering Center. And then we will be talking about later about the visual concept, technology to build the habitat, the functionalities. And then in our evaluation about the future habitat, we imagine some elements related to how much time will be necessary to install this station in Moon. And then we imagine that in the evaluation of the 3 authors, that the Starship would be necessary 3 years to develop the Starship rockets by SpaceX. We had looked we have the follow-up of the development of the rockets in Boca Chica, Texas, and then we believe that 2023 and in 3 years would be possible. We have the landing on the Moon. Okay. And also today is a very special day, because of we are remember the day of the Apollo 11, the birthday of the landing of Apollo 11. And then this is very interesting also to talk about it. Okay, and then we are considered that in more 3 years would be possible. We have a Starship rocket landing in Mars, and then more 2 years in 2025 would be possible. We have a possibility to have the transportation of the modules, the first modules, and then these modules will be used to operate the main station. Okay, in the main station, all things is inside. of the station. And the functionality of this station would be the main issue. One of the important issues is related to some research and tests about food production, and also try not something big, but try to produce food as experience in International Space Station. And then we design a kind of pods that would be possible produce some food like lettuce and also other plants in a kind of test moment, that you know that a lot of food in this moment would be transported from Earth, okay? And then is the first model is more in terms of the very critical to the future operation of a moon habitat. And then we have a success in this moment in 2025. Would be necessary more 2 years in 2027 transporting a module with 3D printed components. In this case, would be necessary we be installing an engineering center. The engineering center would be responsible to use for the use of 3D printing technologies, and try to use the regolith or the lunar soil to transform in 3D printed materials. And then in this moment would be very important the mining in the moon, and try to find the right components and to be used in 3D printing machines. Okay, and then in this moment we would have the operation of the module of the operations of the engineering center in the second moment. And then would be necessary more 2 years in 2029. Also in this the habitat in this moment will be based in the 3D printed components. And also you'll be using glass in this moment to build the main challenge is to build the greenhouse to produce food in Mars. And then we believe that if possible we develop these 3 steps, we would have a very successful experience in terms of build a self-sustainable habitat moon. And then this is the idea that we have about the operation of Lunar Green Habitat and the main issues related. Okay. And then, okay, now we have some final considerations about this concept. During the establishment process, the importance of the development of the habitat since the beginning use a concept of environmental friendly technologies, okay, also allowing greater comfort and well-being to the astronauts. And because of it, we are considering very important also in the first moment of the main station, we find areas to produce food, okay, small areas in the main station like pots to produce food, okay. And then also is important keep the right management and control of entire habitats would be seen as a key of the sustainable presence on the moon. Also, it's important keep updated the research about the innovative solutions, also related to avoid risks and keep astronauts safe for long-term manned missions, okay, or crewed missions. Okay, yes, here we have some references from this presentation. And then this is my contact. And then now I'm able to answer some questions related to some questions from the audience relate our proposal, okay? And then something important that we are considering about our proposal is very important funding to research, and also what our research is developed by the members, the authors, the researchers, but would be necessary, is important, try to see or some kind of crowdfunding possibilities to research we go deeper in terms of research of the habitat. And then this is my email. I can send more details of the research through email, and also send a more completed paper and in as necessary. Okay. Okay. Thanks so much. I'm free to answer some questions about. We have 2 minutes to the next presentation. No? Yes. We are something that I'd like to comment. We are interested to in partnerships, and also try looking to identify possible partners in terms of the education related to Moon and Mars. Okay, and then we are in our YouTube channel is youtube.com/Habitat Marte. And then there is possible to see a lot of presentations with presenting a deep content related to technologies, and also the testimonials of the participants in our missions. Okay, and then everybody are welcome. Okay, to see our YouTube channel. Yes, thanks so much. And then yes, there's thanks so much also Chris and also Christine, and also Ryan for your attention during this time, and also able to help you as necessary. And also I'm also interested to maybe to build a chapter in Brazil. Okay, I'm based in Brazil, and everybody are welcome to cooperate with us. Okay, okay, Francis, I will be writing my email here, if possible, write me, because we consider the technology developed by ESA is very interesting. They have a very strong research group, present some technologies. I believe in terms of activities of the research activities based in situ production are very important, and this is very related to about the use of 3D printing, and I believe this will be a very important technology for the future moon habitat. Okay, yeah, and then let's see the next presenter. Thanks so much, and everybody are welcome. And also I mentioned my Twitter, Julio FD Rezende is my Twitter, and everybody are welcome to contact me using the Twitter, and also mention my name. Okay, thanks so much.